All right, so in this video, we're going to talk about the first part of how to find the inverse of a function. And hopefully you watched several of those videos just to kind of give you a kind of a general idea of how to find the inverse and what a function is. But if you got your highlighters, go ahead and highlight that undo each other. So the whole point of having an inverse function is that it will undo another function. And I kind of like to think of it as Christmas presents. So, like, when you wrap a Christmas present, you cut the wrapping paper, you lay the present down, you fold the wrapping paper on top of it, you tape it down, and, you might put like a bow on top, and then you just kind of address it to whoever it belongs to. Well, the inverse of wrapping a Christmas present would be you opening the Christmas present. So, you're going to find your name on there, you're going to rip the bow off, you're going to rip the paper, and then you have your present. So, it undoes what you just did. Or you could like tie a shoelace and then untie your shoelace. It's the same process. And it's just like that in math too. So if you look right here, you are multiplying by 2 here, and then you are adding 3. So if you wanted to do an inverse function, you would do exactly the opposite of that. So instead of adding 3, you would subtract 3. And instead of multiplying by 2, you would divide 2. And notice how they're in the opposite order as well. So the way that we notate it, when we write down the function, or if you're reading about a function inverse, it's going to look like this. It's going to have a little f, and then it looks like a power of -1, but it's really not a power. It's just the way to write inverse. And sometimes they have of x, and then sometimes they don't. And you just read it f inverse. So it doesn't mean multiply by -1. It doesn't mean it's in the denominator. Nothing like that. It just means inverse. Now, here's something really important, and it was in that first video that you watched. It says, because an inverse function switches the input and the output. So it switches the input and output. That is your x and your y values. It also does the same thing to your domain and your range. So if you have a domain, that's going to be the range for your inverse, and vice versa. So the domain of your inverse is the range of your original function. So you can kind of see that right here. This is the domain. The domain is all of your x values. So the blue one is your original function. If you wanted to find your inverse function, do you see how they flip-flopped? So you swap your x value with your y value. So the domain of the first is now the range of the second. And the range of the first is your input, or the domain, of the second. So if they're inverses of each other and you have tables, it's really easy for you to figure out if they are really true inverses. You just look at all of your coordinates and see if they've been flip-flopped. So it's really easy to tell if a table is going to be an inverse or not. It's a little bit more difficult on a graph, but if you know the trick, you can figure it out. So it says we've got the graph of the inverse is a reflection. It's a reflection of the graph of the original function. There is a line of reflection, and it's right here. The line of reflection is y equals x, and that's true for all inverses. Even the types of functions that you haven't studied yet, it's true for them too. So let me show you what I'm talking about. So I know that you studied y equals x. That's the parent function of a linear equation, okay? So if you want to go ahead and highlight that, you can. That is your line of symmetry. It's a diagonal line of symmetry. And if you think about it, when you have y equals x, that is y equals 1x plus 0 in slope-intercept form. So the 0 means that you start at the origin, and you can just graph the slope, up 1, right 1, and just continue in that pattern. So up 1, right 1, up 1, right 1. And it gives you that perfect 45-degree line of symmetry. And it's true for all of them. So why is this line of symmetry important? It's because if you folded these graphs along that line of symmetry, those graphs would lay right on top of each other. So if you just kind of tilt your head a little bit crooked, you'll see it's almost like a butterfly. It's got that line of symmetry, but it's a diagonal line of symmetry. So inverses graphed with original functions are actually really neat. Okay, just in case it's not, just in case the inverse isn't already graphed for you, what you can do is you can pick out your own points, swap the x and y, and then graph them. Okay, so what does that mean? So let's pretend for a second that this red or this inverse function isn't graphed. So I'm going to find really easy points to label, and I just so happen to have 5 of them. I'm going to write them down. Don't do it in your head. And I've had students in the past want to do this in their head. If you write it down, it's easier. So I'm going to write down each one of these points. So this is 0.15. This is 0.03. This is -1, -2, -1. And this one's -3, -3. So to find the inverse function, all you have to do is take all of your x coordinates and swap them with your y coordinates. So this one right here is going to now be 5, 1. So let's see if we can find 5, 1. 5, 1. Here it is. See, 5, 1. So if it wasn't graphed, that's your first point. And then this one's going to change into 3, 0, which is right here. And then -1, 1 be here. So if you flipped them, it would be 1, -1. And then this one's -1, -2. And then -3, -3 is on your line of symmetry because the x and the y are equal to each other. So if you have a question on your ACT and you don't have time to graph it, you can just imagine that line of symmetry and just kind of see if they're going to be inverses of each other. But you do have to remember you have that line of symmetry. All right. So for this next part, I'm going to teach you a trick. So the trick is to figure out if two functions are inverses of each other. So in the previous lesson, we talked about composition. So take a second and look at this. This one is asking you to plug in G into F. And this one is asking you to plug F into G. So you have to do it both ways to prove that it's an inverse, okay? So the first way you do it, it doesn't matter which one that you pick first, but you just have to do both of them. It's got to be opposite of the other one. This is something that my other class wasn't fully getting. So just make sure that when you do the composition, they are equal to X. If they're both equal to X, that means that they are inverses of each other. That does not mean that they are equal to each other if it's like, let's say you have 20x on one of them and 20x on the other. That doesn't mean anything. It has to be equal to x for it to truly undo the other function. And then fun fact, like I said before, this is literally like I'm going to tie my shoe here and then I'm going to untie that shoe. Or I'm going to wrap that present and then I'm going to unwrap it. It's just going to be whatever your input is, okay? So if you ever see this notation where it's got a function composed with the inverse, it's going to undo itself. Just like squaring a square root or cubing a cube root. It's the opposite and it's just going to cancel it out and you wind up with 4, okay? All right, flip it over on the back. And there's a mistake on here. I'm going to give you a few seconds, see if you can figure out the mistake, because I just told you had to do 2 things and there's a mistake on here. So like I said on the first page, like the first page was right. So this one's asking you to plug G into the F. The second step has to be the opposite of that. So I have to plug in F into G and we're going to have to fix this. That's just repeating the same thing. So we're going to plug in F into G. So we're going to start with G and then f of x is our input this time. There we go. Now, for this to be truly an inverse function, they have to be equal to x, okay? So I'm going to find f of g of x. That's what I want to do. Okay, what is g of x? It is x plus 1 over 3. So I'm going to substitute g of x with the entire function here. Now on the other side, I'm going to write the f function. The f function is 3x minus 1, but this time, instead of writing x, I have to substitute that gigantic function for x. Okay, so just to be clear, this function right here is now going to go here, all of it. Okay, so now all we're going to do is simplify, just like we did the other day. 3 here times 1/3, that's 1/3. It doesn't look like 1/3, but it's divided by 3. These are going to cancel out, and you're left with x plus 1. Remember, numerator, denominator, they can cancel. And then I'm going to drop this minus 1 over here. And then look what happens. 1 minus 1 cancels out, and I have x. Now that is what I want to happen. So that's what it looks like. But I can't stop the problem yet. I've got to make sure that both of them are equal to x. So I'm going to go over here, and I'm going to do the exact opposite of what I did before. I'm going to plug in f of x this time. Okay, so I'm going to look, what is f of x? F of x is 3x minus 1. 3x minus 1. And I have to plug that into g of x. And g of x is x plus 1 over 3. So I'm going to have a big fraction, except for x is now going to be the f function. So this 3x minus 1 is now going to replace the x over here. So I'm going to put 3x minus 1. Okay, it's a little bit different. So I've got 3x minus 1 plus 1 over 3. Look at this. This minus 1 plus 1 cancels out. So I'm left with 3x over 3. 3 divided by 3 is 1. So you have x. And that's what it looks like when both compositions are equal to x. So if both are equal to x, then that means that yes, these are inverses of each other. Why? Because both compositions equal x. Now the good news is if you start out and you plug it in, if one of them doesn't equal x, then you can stop. You don't have to do the second one. Okay, I'm going to go ahead. I'm going to pause the video. And then I want you guys to try the two underneath it and hit play whenever you're done. Okay, so if you look at this first one, I plugged in, I think, the g in the first one, and then I plugged in f of the second one. These are really basic linear equations. So all you have to do is realize that the -5 and the 5 will cancel out. So you wind up with x on both of them, which means that they are inverses of each other. So they are inverses. Okay, so on the second one, started out the same way. So I'm gonna start with plugging in f of x here. And g of x is the cube root of 2x. So I've got to plug it into the cube root of 2x. Cube root 2x will be ax to the third right here. Okay, ooh, that's kind of interesting. So I've got the cube root here. 8 times 2 is 16. X to the power of 3. What is the cube root of 16? Do we know that? I don't think we have a cube root of 16 because cube roots are like 1, 8, 27. So if this doesn't equal to x, then these can't be inverses of each other. So this actually does not equal to x. It's actually equal to 2x cube root of 2. So this is no. This is not going to work. So as soon as you realize that one of the compositions isn't equal to x, then you're done. All right, so we're going to go back to Algebra 1 for a little bit. We're going to find the inverse of a linear function. And I know it's linear because it's got x to the power of 1. And what we're going to do is we're going to follow these 4 steps very carefully. So the first thing you want to do is change f of x to y. So I'm going to put y equals 3x minus 1. Check. Then I'm going to switch x and y. So when I switch x and y, I finally am getting to the inverse of it all. So x equals 3y minus 1. So I always like to switch colors when I'm in the inverse section. So once you swap your x and y, this is the inverse. So now all I have to do is make the inverse all pretty. I've got to get y by itself now. So I'm going to solve. I'm going to add 1. Remember, if you have a choice whether to add or subtract, always do that first. So it'll be x plus 1 equals 3y. And then we get to divide by 3. But when you divide by 3, all of it is being divided by 3. Not just the first term, all of it. So, like I said, we need to clean it up a little bit. So I'm going to say y is equal to. Now it says x plus 1 over 3, which is perfectly fine. We're going to go ahead and we're going to change that to our inverse notation. So swap your y back for inverse of f. So this is a perfectly acceptable answer. I just want to make sure that you're prepared for a second option, just in case your ACT or your benchmark, gives you a different option. So let's say that you don't see that as one of your choices. So what you're going to do is you're going to put a 1 in front of that x, okay? So it's 1x plus 1 over 3. And then you're going to separate it. So you have 1x over 3 plus 1 over 3. Last step. See that 1 over 3 right here? We're going to separate it from the x. So I'm going to write 1/3 x plus 1/3. That's the other option that you might see, especially if it wants you to write it in the form mx plus b. So I just want you to be aware, both of them are good. First option is great. Second option is a possibility. I don't want you to freak out thinking that you're doing it incorrectly. Okay, so on this one, I'm going to start out y equals 2x. And then I'm going to swap. So I'm going to change colors when I swap it because the green is now my actual inverse. This one's really quick. All I have to do is divide by 2. So the 2's cancel out. I have y equals x over 2. You need to change the y back into the inverse form. So I'm going to put f negative 1. So that's inverse of f equals x over 2. Now that is perfectly fine. The only other way that you might see that written out, okay, think about it. If you put a 1 right here in the front, that would be what, 1x over 2? Separate the fraction from the variable. So it's going to be 1/2 x. So they are both possibilities. They're both correct. One's not better than the other, okay? Just be ready for it. Okay, go ahead and pause the video. See if you can do the other 2 real quick, and we're going to check and see it. When you're ready, hit play. Okay, so here's the last 2. Just change f of x to y. And then when I changed over to blue, that just means that that is now my inverse because I flip-flop the x and the y and just get y by itself. So just make sure that when you divide, make sure you divide both of these terms by -1. So that's going to be negative x, and then it'll be positive 1. So last thing, don't leave your answer y. You have to change it back into that inverse notation. And then over here, the easiest thing for you to do to solve to get rid of the 1/3, don't divide by 1/3, multiply by the reciprocal. So that would be the easiest thing to do. And then all you got to do is change it over to inverse notation, and that is it.